Okay, so here's our scenario. We're going to go through this and really break it down. On a math quiz, Elisa and Caitlin solved this equation different ways, but each student arrived at the correct answer. Okay, they both got the right answer. So we're going to describe the steps that each student took. We're going to go through each method, and we're going to see what they did, and we're going to kind of brainstorm, like, does that method work for us? If you saw that equation, what would you do? I hear a few of you saying what you would do. What would you do to solve that? What would you do first? Let's just talk about the first step. Gustavo, go ahead.
I would multiply what I have by 5x.
Okay, so you would distribute. Okay, good. That's one of your options here. So Elise solved it this way. So Elise did exactly what Gustavo mentioned. She distributed, and she had 5 halves x, because 1 half times 5, x, minus 3. 1 half times negative 6 is negative 3, equals 3x. Okay, from here, she subtracted 5 halves x from each side. Why do you think she did that? I think we're actually going to talk about this in a little while, but why do you think she did that?
So she can get rid of the x.
So she wanted to isolate the variable. She wanted to move all the variables to one side. Why do you think she took away that 5 halves x and didn't subtract the 3x from the other side?
Because if she did subtract 3x, it would be a little harder to find the final answer when your x is a fraction.
Okay, it could have been a little bit more challenging. What else would have happened? So 5 halves x, what is that as a mixed number? 2.5. Good. So why do you think she did 3x minus 2.5x instead of 2.5x minus 3x?
Maybe because it's easier to deal with variables with fractions when they're like, I don't know. I think it's irregular, right? I don't know.
Or
It's a mixed number. I don't know. But I think it's easier to do it that way.
Okay. So you think she prefers to work with a mixed number?
Yeah.
Okay. After she isolated her variable, her 5 halves x is no longer on this side of the equation. Notice that this is a negative 3. A lot of us want to just turn that to a positive 3. But we are not changing the value. So now we have negative 3 equals 1 half x. And what's the last thing she did?
She divided 1 half on both sides.
Why'd she do that?
So she can get her x.
So she can get x by itself. Because what's happening here between x and a half? X is being multiplied by 1 half. So to undo that, we divide. Negative 3 divided by 1 half. Negative 3 divided by 1 half is the same as negative 3 times 2, which would give us negative 6. A lot of us still get a little worried when we see those operations with fractions. Okay? Is there any other way? So that's how Elise did it. Let's see. Is there any other way you could have started? And I mean like here. Besides what Gustavo and Elise did, is there any other way we could have started this?
And we could have multiplied by 2 sides.
Yeah. So Caitlin multiplied both sides by 2. Why'd she do that? I don't want you to answer because I know you understand this. Why did she do that? And this may be something that you all look to when you're working with problems like this as a strategy that may help you. Why did Elise do this? Or I'm sorry, Caitlin. Take a look at what she did because some of you may never have seen this as an option. But you should all be looking at the board.
Can she do that? Is that okay? That she did that?
Why is she allowed to do that?
She's doing it to both sides.
Whatever you do, as long as you do it to both sides, your value hasn't changed. So she is absolutely allowed to. She can multiply both sides by 1,000,000 if she really wanted to, as long as she did it to both sides. So we know she's allowed. Why did she choose the number 2? Because that's where the real work comes in. Kevin, what do you think?
To get rid of the fractions, to make it like a whole.
Yeah, good. I love how you took what you were saying with to get rid of and you said to make it a whole. Absolutely. She's multiplying here. 2 times a half. 2 over 1 times 1 over 2 is what? It's 1 whole. 2 over 2 or 1 whole. For those of you that just don't like working with fractions, she got rid of it. And I know that that's like a non-mathy way of saying she multiplied to make a whole number. But because she did that here, she had to do that here. Okay? So she ends up with this. Why is the parentheses gone now?
She doesn't have to multiply by anything.
So now there's nothing there. There's nothing here to multiply. Really, it's the number 1, but I don't need to show a parentheses to show that I just multiplied everything by 1. Okay. From here, what does she need to do? I know you're seeing the steps, but what does she do from there? 5x minus 6 equals 6x.
She removes the variable.
Say again.
The
Move the
variable.
Good.
Oh, did I say
You
variable?
said valuable. It's okay. I knew what you meant.
She moves the variable to the right side.
So she isolated her variables. And when we do that, we remove them from one side of the equation. She removed the 5x here so that there is no longer a variable on this side. And then she did the same thing to the other side. So her equation is done. Okay. So notice there's 2 ways you could say it. So many of you go right to the distributive property. You're not wrong. You've worked with the distributive property for so long that a lot of you are just, it's ingrained in your mind to do that. Okay. So Elise's second step, no, we actually already talked about that. Could she have done something different here? She decided that to get x alone, she had to divide both sides by a half. Think about what operation, instead of writing it all out, what could she have just done right away?
Multiply by 2.
Yeah, she could have, instead of saying like divide by a half and then going over to the side like I did on the slide previous and saying 1 over 2 is the same as multiplying by 2. She could have just said, dividing a half, I know I'm just going to multiply by 2. Okay, she could have done that. Did she need to subtract the 5x? And this is a big one. Some of you are still making this tiny, tiny mistake. Did Caitlin need to, now take a look at this equation right here. Did Caitlin need to take away the 5x? And then take it away from the side? Like, did she have to do that? Is there a rule that tells you what needs to go? No. Why do you think Caitlin avoided subtracting 6x from both sides? Take a look at what would have happened if she subtracted 6x from both sides. Why do you think she avoided doing that? Would she have been allowed to subtract 6x from both sides? Yeah, as long as she did it to both sides, she could have. Why didn't she? Marco.
She would have negative 1x.
So she would have had negative 1x, but what else? What would have been a big problem then?
The variable and the number are going to be the same size.
Yeah, that would have been a little bit of a problem. Oh, I didn't realize it. Because the variable and the constant would have been on the same side of the equation. Look what I could have done here. If she did this, and some of you are making this error, so we want to identify. If she took the 6x away, this equation would have been negative 1x minus 6 equals, there's nothing there. Okay? So that, can I still have an equation like that? That's a band 6, I'm sorry. Could I have put a 0 there? Is there truly nothing on that side of the equation? That would be correct. True. There is nothing there. What would I have to do now?
Add 6.
Yeah, I would have had to have added 6 to both sides. Or, if I didn't want to add 6, I could have added 1x to both sides. So I would would have ended up with -6 equals x. It still could have worked, but that she actually would have made more work for herself. So for those of us that are doing that, and we're kind of putting everything on one side of the equation, we're making some mistakes because some of us are doing this, and then we're just saying like we can't just add in that equal sign. Or we need to be really methodical with how we're going through the process. Which method do you prefer? Elise there's no wrong answer here. And I'm not saying that you know how to do both fluently, but if you knew how to do both scenarios, Elise and Caitlin, which one would you do if you could do it regularly? There's no wrong answer. So you can just share what you think. Mortimer, what would you do?
Probably Caitlin,
Okay, why?
because hers seems to have all whole numbers, and when you're dealing with whole numbers, it's way easier because that's what you know.
Okay, so maybe Caitlin's because you're gonna kind of get rid of working with fractions early on. How about like in terms of the number of steps through, do you feel like Caitlin's might be a little bit more straightforward?
Yeah.
Okay, anyone like Elise? Now, if you're not 100% comfortable with this concept, there's a good chance you'll continue to do Elise's concept the whole year. Why do you think students would venture to do her concept, Elise?
Because they learned it longer and they really understand.
Yeah, you've been working on the distributed property for quite some time. So for a lot of you, when you see 1/2 outside of the parentheses, your first thought, and maybe your only thought, is to just multiply. Some of you may not have gone to, well, I can actually multiply by 2 to make that a whole. Now, you may not have gone there. We're not gonna go to that. So at your table, okay, with a small group, in your binder, you're gonna answer this on your own. And then you're going to share with the people at your own table. 1/4 parentheses x minus 4, close parentheses, equals 3/4 x minus 5. So do this in your binder and then share with the people that you're sitting with what you got. And let's see if we can all come up with a correct answer. Think about Elise's method and Caitlin's method. If you want to try Caitlin's method, you can. Be careful with what operation you're utilizing.
I'm gonna try.
If you want to do both methods, you can, because then you would know if you were right. First thing you're supposed to grab. You're welcome. But when you do this, so this won't be there. That's the change. Like normally students would do that part, then they would mess up. You got that part perfectly. But 4 times 3/4 is going to give you what? Perfect. Right, so this. Oh, okay. I'm just like, okay. subtracting a quarter, you're subtracting a quarter back. Right, you can't just leave the variable, that's not subtracting. Right, if you remove it, you multiply it. So this is not. See that? From here, and your inference is so consistent, so you need to be on this right now. From here, your value, from your constants need to go. So here, you wouldn't subtract the 1, because then you would end up with. That's a 1. You can save yourself a step. See why I did that? So now try to finish that. So once you have an answer, share out with the people that are at your table and see if you can problem solve any of the little errors within your small group. So if I do this, which you can do, I'll multiply the whole 7, you're multiplying the entire side. So this is good, but then this, you didn't multiply it by 4. Did you do the same thing? Yes. So here, you can't, this is multiplication, so you can't subtract. So you have 2 options. You can distribute it and just multiply it through, or if you want to get rid of it, you would have to multiply by 4, because that would make 1. Whatever you decide to do the other side. Try that again. Make sure that the people at your table have all come to an agreement on the solution. Okay, so what did you do to start? Like, how'd you go from this? No. What was that one? Yeah, so you use the distributive properties.
End up getting 3x, and then after you get 3x by 16.
How did you get?
I got most of them.
Good. Now, here, you do that into the whole side. You're not gonna make that mistake. So we're seeing a common mistake amongst the whole class, which is something very good that we can identify. So we will. Raise your hand if your table has a solution. If all 7 tables have a solution, that they feel like you're either on the right track or you're done, you've kind of conferred with each other.
Alright, so I got what I need to give, but I don't know.
What is it?
You're almost done here. You're good here, you just have to finish.
I don't know.
All the variables on one side, all the constants on the other side.
Hey.
How'd you get that?
Because when you multiply the whole side by 4, you get 12.
I love this one.
So I will work 4. It would be 3x.
Okay, so I'm gonna pause you here. That's the answer.
How was that?
If you didn't get it, talk with your table on how you didn't get that. Because a lot of you feel pretty confident and you're like just hanging like, yeah, I'm good. And you didn't get that. So go through again and look at what you did and try to spot your own mistake.
Look. That's 24.3. All I need is that 8. I don't know where I'm supposed to do that.
Hey, was I doing right? Did I answer right? Or did I? Wait, no, I think it is. I don't know.
Raise your hand if you had x equals 8. Anyone here? You were on the right track. You just did that one thing wrong. Okay, good. So we have just about one person at every group that got it, right? So that person, try to explain to the other people what you did. Maybe at least just show them your notebook. So let's see what we did.
So,
You just showed me.
Me?
Yeah.
I didn't get it.
That's great.
I don't know. I know I'm not sure.
Did anybody get? Okay.
then after that,
Let's see, what's the deal?
so that's right.
So why did you subtract this? Now you're saying no, you're gonna subtract. You're subtracting your quarter. So you see how over here you went from 3/4 times 2 quarters. You can't do this.
So you multiply 4
Now,
and I love
negative 1.
how you multiply 4 by each of the terms on the right side.
Now you're good.
Because I just multiply 4 on the side of the row, we have to multiply 4 on the other side. But the entire other side of the equation solve that, okay? Every term. So I love how you did that, because that's a very common mistake. So you multiply 4 times 3 x and 4 times 9.
If I have 2 quarters x minus 4, what am I
So
doing?
it's back
Well,
to
you did it on purpose.
4 times a fractional whole. Right? Half. So never in there.
What operation is this?
Then you add 4.
Yeah, so but yeah, that's what it's not. So on the side, but not just one term, both sides.
You add
So now this
So
is
you multiply 4 times 3 x and 4 times
4 divided by 2. Jayla, do you know the 5?
Okay, so
after that you don't
on the left side, that's the whole time, that's x minus 4. But so on the right side,
We got one.
Take a look and see. Now, which is this. And now again, as a comment.
Oh, 4. Oh, yeah. Yeah.
Excuse me, would you dismiss Giselle Ortiz? She has a dental appointment.
So you, from here,
so
so all the variables have to go there. Subtract 2x.
So I'm gonna be 3.
Or, I'm sorry, subtract 3x. The x minus 3x is
It was minus 1.
negative. Okay, let's start to go over this. There's some really good discussion, and I like how, which we'll try to do that moving forward, like just showing you the final answer so that you have to go back and figure out where you went wrong. So let's talk about some of the common mistakes. And I'm just going to write some notes for myself, because that was one common mistake, and then this was a common mistake. Okay, how can I start this? So for those of us who did Caitlin's method, where we didn't distribute, we actually multiplied by 4, okay? We can multiply this side by 4, okay? What do we have to do here? What was the mistake? So we need to multiply by 4, but you're multiplying the whole side by 4. Some of you just got negative 20, which I actually thought most of you were going to get the 3/4 multiplied right, and you were going to forget the negative 5. Most of you actually forgot the 3/4. If I multiply this, I have x minus 4 equals 3x minus 20. How did I get 3x? 3/4 times 4 is 12/4, which is 3. Key mistake. So if I were to continue this and solve it, what would I do? So at this point, you have some options. You have variables on both sides. We need all of our variables on one of the sides to isolate, and then our constants on the other side, so that we get that format. You want to go, Ion?
Add 4 to both, -4 and negative.
Okay, so you're going to add 4 to -4 and -20, which gives me, and notice when I do this, I rewrite the whole equation. Otherwise, for some of these complex equations, it can get crazy. What do I have here?
6 negative.
Now what?
You could, subtract 3x.
I need here, if I'm at this point, now if you take the x away, you're going to add some steps. But here, notice that I can actually isolate my variable to one side. If my constants are here, I can send my variables or isolate my variables to the left side by subtracting 3x. So what do I have? On the right side, I have -16. What do I have on the left? X minus 3x. -2x. Last thing to do. Divide by -2. X equals 8. Good. So let's talk about the other mistake. The other common mistake is for those of us that distributed. If I distribute, what do I get? When I distribute that 1/4, what does the left side become? If I multiply it. Okay. How did we get -1?
You multiply 1/4 by 4.
1/4 times -4. It would be -4/4. That's a -1. And on the other side, now what? Here comes the mistake.
Wait,
Okay.
okay, so what I did was, you add 1, then you add 1 over there, so that's like 1/4 x, and then 3/4
Wait, hold on.
minus.
Say again?
You add 1 on the left side, and then you add 1 on the right side, and then you multiply.
Okay, so 1/4 x equals 3/4 x minus 4.
And then to make it easier, I like multiply by 4. Like 4 times 4 over 4 is all x. Like you put the x. Okay, you multiply each side by 4.
Right, so at this point, Gustavo decided that he wanted to multiply both sides by 4. Could he do that? Yeah, if he did that, he would have ended up with x equals 3x minus 16. Why the minus 16? If you multiply both sides by 4 at this point,
Because you multiply 4 by 4.
because you multiply by the whole side. For those of us that didn't do, that's a good strategy. The majority did something different. What can I do from, and actually I'm going to back it up. So here. For those of you who distributed, what'd you do from here?
Subtracted 1/4 x.
Okay, so we can take the 1/4 x away. Key mistake. Can I do that? A few of you did this, okay? And you ended up with, what's the problem? Take a look at what just happened here, okay? Because a few different groups did that. What happened? What's the issue?
I don't know if it's right, but maybe if you think about it, like 3x, 3/4 times 6, like if you just minus 1/4, like I don't know. Never mind. I don't know.
What's the issue?
They're not the same.
What's not the same?
The 1/4 x and 1/3.
Okay, so if we subtract this, the operation here made sense if you forgot to bring that variable over here. 3/4 x minus 1/4 x would give you 2/4 x. You can't just subtract 1/4 from 1/4 x. They're not being added together. What operation is this? That's multiplication. The only way you can get rid of that 1/4 is to divide. But the idea is good in that we want to isolate our variable. If you subtract properly, there is no x here. Then what will we do to solve? How would we get x alone here?
Add 5 to both sides.
So 4 equals 2/4 x. And then? Last thing, how do we get x alone?
Divided by 2.
Divide by 2/4. So 4 divided by 2/4 is the same as 4 times 4/2. 16/2. 8. So the key is that when you're isolating the variable, that you are properly isolating. Meaning if you're going to subtract something from one side, make sure that what you're either subtracting or adding or multiplying, dividing makes sense to what you're doing. You don't really want to leave stuff behind. Okay, for your DOL, we're going to solve this. However you choose to solve that on your DOL sheet. Okay. Before you start, when you are done, DOL sheet can go in the bin. And then we need you to do this worksheet tomorrow. We're doing the lesson, but we need this sheet done so that we can first identify any of the common mistakes. It actually helps us create the lesson. So when you are done with your DOL, the sheet's going to be right next to the DOL bin. Please take one and begin. It does have a front and a back. The notebook paper.
We just handed it back to them. You're gonna write it on the same notebook paper that we just handed back.
Yeah, no need to use a new sheet. Use the one that we handed back at the beginning of class. We like to save paper. Yeah.
It's gonna be a problem all year long. So I'm gonna give her an entire lesson. I don't like this. What can I get? Performance coach. I almost want to just give the website link for the YouTube video. She'll see every lesson, right? Like
Yeah.
she's missed everything.
Yeah.
Okay.
This is what I was gonna ask you.
With what? How to solve them?
Yeah.
If you're confused with the assignment, I want you to put it back. Because that's one of the most challenging ones for what we're learning right now, so we may not have learned how to do what it is you're doing there. Right, because that's a 10,000 point assignment, so maybe try a 2,000 point and work your way up.
I can do it though.
What is it?
I thought so.
So they built it for you. They showed you like the number y, and you're gonna have 1 to it, and you're gonna divide it by 3, and then your answer, your output is 2. So how would you undo this? Like how would you solve it to get y by itself? Identify what's happening.